So after having a super short first topic or subtopic in Journal 1's 2, it was part 4 of 10 here. We've got a kind of lengthy part 6. So we have to know that the change in momentum is the impulse, which is given the lowercase j, and we want to relate impulse to acceleration in Newton's second law of motion and apply the concept of impulse to explain the functioning of a variety of safety devices. This almost feels like 3 jobs. The first one is done. Change in momentum is change in impulse, which in cases where mass is constant, so if you're not a rocket burning fuel or something like that, it's mass times the change in velocity to produce the impulse. Now, how do we relate that to Newton's second law? Newton's second law says F equals ma. Well, what is A? A is delta V over delta T. Wait a minute, this is starting to look familiar. M delta V is the change in momentum when our mass is constant. So force is really just the change in momentum over the change in time. Or if we want to tie it to impulse, our impulse is the force multiplied by the time over which that force is applied. So, how does this relate to safety devices? Well, if you want to be safer, you need to reduce the force that you feel during an accident. So how can we decrease the force? Well, the momentum change, or the impulse, is going to be the same. Right? If you're driving a car and it's going 100 kilometers an hour, and you hit a brick wall or another car, something that brings you down to 0 kilometers per hour, well, that impulse is just 100 kilometers an hour times your mass. Nothing is going to change that. But it's not the impulse that gets you. It's the force. It's how hard you were pushed when you were brought to a stop. So if you cannot change impulse and you want to reduce the force to make things safer, you increase the time it takes to stop. Seat belts will increase the time it takes to stop, slowing you but bringing you to a stop before your head hits the windshield. Most cars now have crumple zones. So instead of being a rigid box that barely takes a dent when you hit the wall, they're designed so that your engine is going to completely collapse and try to protect the passenger cabin, because this will increase the time it takes you to stop. Increase the time, decrease the force. This is the connection to safety features that we are looking for. And this is also a part of Unit A, or the first of 4 units in Physics 30.